Hello, in this video, we present the retrosynthesis of isotopically labeled phenobarbital with deuterium, specifically penta-deuterated phenobarbital. This isotopologue can be useful in the research of pharmacology, metabolism, and as an internal standard in bioanalytical methods of this drug. In general, the retrosynthesis generates the labeled disubstituted malonate as the first precursor and urea as the raw material. This precursor, in turn, can be prepared from commercially available and accessible raw materials, with the primary source of deuterium being deuterated water, as we will see later. The endocyclic urea fragment functions as a retron and two carbon-nitrogen disconnections, result a substituted malonic ester with a penta-deuterated ethylic chain as the first precursor and urea as the raw material. The deuterated chain is attached to an alpha carbon to the two ester groups. This structural feature allows for the introduction of the chain through a substitution reaction between the labeled ethyl bromide and the phenylmalonate 5. The labeled ethyl bromide can come from penta-deuterated ethanol 6 through a functional group transformation. Another functional group transformation based on the reduction of the carboxylic group results in trideuterated acetic acid 7. The labeled acetic acid can be considered as coming from the decarboxylation of labeled malonic acid 8. The introduction of a carboxyl group in 7 forming the labeled malonic acid 8 facilitates the introduction of deuterium atoms in its alpha carbon. And thus, two carbon deuterium disconnections in 8 generate malonic acid 9 and deuterated water, both as raw materials. Finally, the malonic ester 5, substituted by a phenyl group in its alpha carbon, through a carbon-carbon disconnection based on a catalyzed arylation, gives rise to malonic ester 11 and phenyl halide 12 as raw materials. In summary, here are the main disconnections. In the next video, the resulting synthesis will be presented.